Section 4.4, more equations and applications. We recall what we did in the previous section. The first thing we did is we have this property log x base a equals m. That's the definition from not the previous section but 2 sections back. Then a to the m is x. That was the definition of log. The properties we presented in the previous section was log x times y becomes log x plus log y. So the multiplication becomes addition. Log x over y is log x minus log y. Division becomes subtraction. And the next thing is log x to the m base a is m log, so you can bring the m down. M log x base a, m log x base a. So we can use this to solve some logarithmic equations. Let's say we are asked to solve this. Log x base 3 equals 2. The way to do that, you use the definition of log. The main thing to drop the log function is to use the main definition of log. And that can be done when we use the definition of log is rewriting this 3 square equals x. So x is 9. And just keep in mind, on the right side, I wrote down if we have y equals log of fx base a, always fx is bigger than 0 for all x. For all x. Next example, log x, log 25 base x equals 2. Again, we use the definition of log. We use the definition of log. So we do x squared is 25, x squared is 25. So x here should be plus or minus 5, plus or minus 5, but the base cannot be negative. Base cannot be negative, so only x equals 5 because base cannot be negative. Next one, solve this equation. Log w minus 2 base 6 plus log w minus 1 base 6 equals 1. How do we solve such equation? We multiply the first two on the left side. Log w minus 2 times w minus 1 base 6 is 1. So 6 to the first power, 6 to the first power equals the w minus 2, w minus 1. Then we distribute the left-hand side. W squared minus w minus 2w plus 2 equals 6. Subtract 6 on both sides because it's a quadratic equation. Combine like terms, like the 2 minus 6 is negative 4. And this is really factorable as w minus 4, w plus 1. And here we get two values of w. One w equals 4 and one w equals negative 1. But it can't be negative 1 because if you look at the equation here and you put negative 1, you're going to get negative 1 minus 2 is negative 3. That will give us a negative value. Log doesn't take negatives. Log doesn't take negatives. Remember, only bigger than 0. Can't take negative or zeros. So that's why only w equals 4 works for this equation. Another example, but this example has natural log. So natural log of x plus natural log of x plus 2 equals natural log of 8. So how do we do this? So we multiply the left-hand side together. So multiply ln of x plus ln of x plus 2 becomes ln of x times x plus 2 equals ln of 8. Now we can drop the ln by doing e both sides. So the ln get dropped. Then we can distribute the x in and subtract 8 because it's quadratic. We must bring everything to one side, set it equal to 0. Then factor x plus 4, x plus x minus 2 equals to 0. And set it equals, you get negative 4 and 2. But again, it can't take the negative 4. Natural log or logs doesn't take negative values. How about next one? Log 6 plus log x equals log 3 minus log x. How do you start with this one? There's many ways. You can combine, for example, the ones on the left by, because addition becomes multiplication, and the ones on the left, because the subtraction becomes division. So log 6x equals log 3 over x. Then you can drop the logs, you get 6x equals 3 over x. Cross multiply, you get 6x squared is 3. Divide by 6, you get 1/2. Then what is x here? What is x? X is plus or minus the square root of 1/2. Plus or minus the square root of 1/2. So that gives me plus or minus 1 over square root of 2. If you rationalize it or you leave it, it's fine. But again, x can only take the positive value, can't take the negative value. Okay, we can't take the negative value. Even if you try to substitute negative 1 over log 2, negative 1 over square root of 2 into the calculator, you will see the calculator will give you an error. The calculator will give us error. So we can't substitute that in. How about 3 to the x equals 5? What makes this equation difficult is having the exponent as a variable. So to clean that or to bring the x down, the only way is to do log both sides. But notice you can try to do the you can use logs to bring the x down, and then you can use base 3 because the base is 3 there, or you can leave it as log base 10. So if there's no base, means base 10. Then you bring the x down, log 3 equals log 5, then divide. So that gives me about 1.4649. Next example, we have on both sides I see x's, not just as one side as it happened in example 6. So what do we do here? We're going to do log both sides, but to do log both sides, we can do log base anything, 2 or 3, or just keep it as 10 as I did in the previous example. So I'm going to do log both sides base 10. Then that will help me to bring all the variables down, the x down and the x minus 1 down. And after we do this, we multiply the x in, x log 3 minus 1 log 3. Then what? We can subtract x log 3 on both sides equals negative log 3. Negative log 3. Why do I do this? Because I want to solve for x. So I group the terms involving x on one side. So I can factor x out and then divide both sides by, or you can combine them first, log 2 over 3, and then divide by that. And if you put that in the calculator, that gives me about 2.7095, 4 decimal places. Next example, I see 2 different bases, one base e, one base 3. Again, you can do log both sides base 10, or if you like to do natural log of base e, which is base e, so you can do ln or natural log both sides. That will help us to bring the 2x down and the x plus 1 down. Remember, natural log of 1 and natural log of e is 1. So on the left side, I'm only left with 2x. On the right side, I multiply the x in, x natural log of 3 plus natural log of 3. Then I need to group the terms with the x, the term x involved on one side. So I have to subtract x natural log of 3 on both sides. And the next step is the trickiest step, is factor x out. That's something students forget most of the time. Then we can divide both sides by 2 minus log 3. You can either put this on the calculator and see the answer, or leave it like so. Now let's look at an application, half-life application. The half-life, why do we call it half-life? The half-life is the time it takes a substance to decay to its half. So we say that here, the half-life of a radioactive substance is the amount of time that it takes for 1/2 of a substance to decay, 1/2 substance to decay. And this is modeled by this equation, A equals A0 or A node e to the RT. A0 is the initial amount, A is the final amount, R is the rate, and T is the time. So that's what I wrote here. Time must be in years. Time must be in years. So if we look at this example, If the half-life of a drug is 12 hours, then at what rate is it being eliminated from the body? Since they're talking about half-life, I can write the formula down. So since the amount is going to become half of the original, so always A is going to be 1/2 A0. So I substituted that in 1/2 A0 equals A0 ER, and the time is given 12. We need to find R. Notice you can divide both sides or cancel A sub 0. That will leave only 1/2 e to the 12R. And that's where logs kicks in, is that helps us to solve for R here by taking, because the base is E, we can use natural log both sides, natural log. And then the left hand side stays the same, but the right hand side you bring the 12R down, natural log of E. Natural log of E is 1. That will give me just 12R on the right side. Then what we can do to solve for R is divide both sides by 12 and put that in the calculator, give me negative 0.05, which is about negative 5%. That's the rate, negative 5%. So that was an application, is how logs or natural logs can be used to solve real life applications.